Welcome to our nocturnal laboratory of gentle discoveries. Here at Dreamtime Science, we transform complex concepts into lullabies for the curious mind. You know, I've been thinking about something that feels almost like a cosmic daydream. What if there are enormous glowing structures out there, built by alien civilizations to capture the energy of their stars? There's something remarkable about the idea that we might one day spot these giant Dyson spheres, huge bubbles of light and power swirling around distant suns. It's like a gentle whisper from the universe, inviting us to wonder just how far life and imagination can stretch beyond our little blue world. Should you find solace in these cosmic lullabies, consider becoming a regular dreamer by subscribing. Share what topics intrigue your curious mind in the comments below. Now, take a moment, adjust your blanket, find the perfect hollow in your pillow, let your shoulders melt, breathe in and out. In the hush of the night, when city lights have faded and the world lies in gentle slumber, the sky reveals its ancient secrets. Overhead, the black vault is dusted with countless pinpricks of starlight, each a sun, burning across distances so vast they swallow thought itself. The Milky Way spills its misty river from horizon to horizon, a cosmic tapestry woven from billions of stars, each one a furnace of unimaginable power. To gaze upward is to peer not just into space, but into time. For those glimmering dots are messages dispatched long before the world you know was born. As you lie back and let your eyes adjust, a question as old as wonder itself begins to whisper. What might be possible out there for minds older and wiser than our own? Consider for a moment the energy in a single star. Even our own modest sun, from 93 million miles away, bathes the earth in enough light to warm the air, stir the winds, and feed every green leaf. Yet, for all the sunlight that falls on our little blue world, it is but a tiny fraction, less than 1/2 billionth of the sun's total output. The great star pours forth its radiance in every direction, and almost all of it sails on into emptiness, unclaimed, unused, lost to the black between the worlds. All across the universe, this is the normal state of things. Stars burn, planets orbit, and a staggering torrent of energy streams away into the void, wasted by the standards of any civilization hungry for progress. For most of human history, we could only marvel at this abundance, powerless to catch even a drop beyond what happened to land on Earth. Yet as our understanding of the cosmos deepened, a daring thought began to take shape, a thought both audacious and serene. What if an intelligent species could find a way to capture all the energy of its star and bend that power to its will? This, in its essence, is the dream of the Dyson sphere. The idea did not spring fully formed from a single mind, but it is most often traced to a British mathematician and physicist, Freeman Dyson, who in 1960 penned an essay that would ripple out through science and imagination alike. Dyson was not, at heart, a science fiction writer, but a scientist who liked to think in grand terms. He reasoned that as civilizations advanced, their appetite for energy would likewise grow, and that eventually the surface of a planet would become too small a stage for their ambitions. Why cling to the meager surface of a world, he mused, when the full radiance of a star blazes just out of reach? Dyson's original vision was not of a solid shell, an impossible rigid cage around the sun, but rather a vast, diffuse swarm of orbiting structures, each one designed to intercept a portion of the starlight. Solar collectors, habitats, power stations, satellites, together forming a loosely connected cloud, a living shell whose inhabitants would dwell in perpetual daylight. Over time, this concept would be distilled and transformed by the alchemy of storytelling. writers and dreamers seized upon the notion, reimagining it as a titanic artificial world, a sphere so enormous that its inner surface could contain the land area of millions of Earths, bathed in the unfiltered glory of the sun. In the landscape of science fiction, the Dyson sphere became a symbol, a monument to the ultimate reach of intelligence. It is both a feat of engineering and a kind of cosmic poetry, the harnessing of a star, the transformation of chaos into order, darkness into light. In countless stories from novels to television, the Dyson sphere is presented as the hallmark of a civilization that has transcended planetary limits. It is the threshold between the merely advanced and the truly cosmic. But before these ideas took root in the popular mind, the seeds had already been sown in the soil of earlier imagination. In 1937, the science fiction writer Olaf Stapledon described, in his sweeping novel Star Maker, a future in which intelligent life spreads across the galaxy, building shells around their home stars to capture all their energy. Stapledon's vision was less technical blueprint and more philosophical musing, yet it planted the idea that such feats might lie in the destiny of intelligence itself. Dyson's own reflections, as he later admitted, were partly inspired by this earlier tale. He was not so much proposing a construction project as suggesting a way to recognize the handiwork of advanced civilizations. If a cloud of solar collectors surrounded a star, much of its visible light would be blocked, and the waste heat would be re-emitted as infrared radiation. Thus, he reasoned, astronomers might detect distant Dyson spheres by searching for stars with an unusual excess of heat. The concept became not just a feat of engineering, but a kind of cosmic signature, a way to peer across the darkness, searching for evidence that we are not alone. In the decades that followed, the Dyson sphere blossomed in the fertile ground of fiction. Its allure was irresistible. To imagine a structure large enough to enclose a star is to confront scales so vast they teeter on the edge of comprehension. In Larry Niven's celebrated novel Ringworld, the sphere is replaced by a single slender ring encircling a sun, its inner surface home to landscapes, seas, and civilizations. The British television series Doctor Who depicted a Dyson sphere as a gigantic habitable shell, its interior horizon arching away to impossible distances, its light gentle and eternal. Other stories imagine spheres as arcane, godlike constructs, machines built by vanished beings, their purposes lost in the haze of deep time. Yet for all their differences, these visions share a common thread, the notion that intelligence, given time and ingenuity, seeks to transcend its cradle. The Dyson sphere is not just an object. It is a metaphor for the boundless hunger of life to expand, to explore, to master the elements of its own existence. It is a monument to hope, and to the belief that the greatest wonders lie not behind us, but ahead. From a scientific standpoint, the Dyson sphere invites both awe and skepticism. The sheer scale defies ordinary comprehension. To build a shell or swarm that could intercept even a significant fraction of the sun's energy would require materials, labor, and coordination on a scale far beyond anything humanity has accomplished. The inner surface of a solid shell, for example, would have to span a distance of nearly 300 million kilometers in circumference, and possess enough strength to withstand the relentless pull of gravity and the pressure of sunlight. The material requirements alone would dwarf the mass of all the planets in the solar system. Even a more diffuse Dyson swarm, a cloud of independent collectors, would demand staggering resources and untold ingenuity. Yet it is precisely this audacity that makes the idea so compelling. The Dyson sphere is less a blueprint than a provocation, a way to stretch the imagination, to ask not merely what is likely, but what is possible. It is a challenge to the quiet tyranny of the probable, an invitation to dream in units of stars and centuries rather than years and watts. Popular culture has seized upon the Dyson sphere as a symbol of ultimate achievement, a destination at the far end of the road of technological progress. In games, films, and stories, it appears as the crown jewel of super-civilizations, a place of endless daylight and limitless energy, where the old constraints of scarcity and struggle have been left behind. Sometimes it is a utopia, glittering with cities and gardens beneath an artificial sun. Sometimes it is a tomb, its builders vanished, its halls echoing with silence and enigma. It is both aspiration and warning, a reminder that power without wisdom can be as perilous as it is glorious. In the collective imagination, the Dyson sphere takes on many forms. Some envision a smooth, featureless shell, its surface gleaming with the light of 1,000 cities. Others imagine a vast latticework, a mesh of solar arrays and habitats, ceaselessly orbiting in an intricate dance. Each vision reveals a different face of the idea, a different answer to the question of what a civilization, given enough time and will, might achieve. What is it about this dream that so captivates us? Is it the sheer scale, the sense of stepping beyond the narrow limits of our world and grasping at the very heart of creation? Is it the promise of abundance, a future where energy is not a constraint, but a canvas for invention? Or is it the yearning for a kind of immortality, a place where life can endure as long as the star itself, sheltered from the cold indifference of the universe? Perhaps it is all of these and more. The Dyson sphere is not simply an engineering challenge, but a question posed to the universe. What is the fate of intelligence if it endures? Will we, or others like us, one day leave behind the fragile shelter of planets and dwell in the light of our own making? In the quiet hours, as darkness settles and the stars wheel overhead, such thoughts take on a peculiar clarity. The universe, vast and ancient, cares nothing for the dreams of small creatures on a minor world, and yet it is through such dreams that we have come to know the stars at all. The Dyson sphere, in all its impossible grandeur, is both a symbol and a problem, a challenge thrown down across the abyss, daring us to imagine not just what is, but what could be. As you listen, let your mind wander outward, beyond the familiar, into the realms where science meets fable. For in the Starlight Symphony above, every note is a question, every silence a possibility. The Dyson sphere is but one answer, a chord struck across light years, resonating with hope and wonder. Yet, beneath the poetry, there is a deeper current. To contemplate the Dyson sphere is to confront our own place in the hierarchy of the cosmos. Scientists have devised frameworks for measuring the progress of civilizations, and at the heart of these lies the mastery of energy. The Russian astrophysicist Nikolai Kardashev, for example, proposed a scale, now known as the Kardashev scale, dividing civilizations by their energy use. A Type 1 civilization commands the resources of a planet, a Type 2 the full power of a star, a Type 3 the energies of an entire galaxy. The Dyson sphere, in this schema, marks the boundary between the parochial and the celestial. It is the emblem of a species that has learned not merely to survive, but to shape the fate of its own sun. In fiction, this journey is fraught with peril and mystery. The builders of Dyson spheres are sometimes depicted as wise and benevolent, sometimes as reckless or even monstrous. The sphere itself may be a paradise or a prison or something stranger still, a riddle wrapped in machinery, echoing with the footsteps of gods. Yet always the idea persists that somewhere, perhaps far away, perhaps long ago or yet to come, minds may have arisen that looked upon their star and saw not just a source of warmth, but an invitation to build, to dream, to reach beyond the ordinary and touch the fabric of the cosmos itself. So, as the symphony of starlight plays on overhead and your thoughts drift between wakefulness and sleep, hold close this vision, a sphere of light, immense and silent, turning in the dark. What stories might such a place hold? What lives? What wonders? What mysteries? The journey toward that distant dream has only just begun, and the music of the spheres still calls softly, just beyond the edge of hearing. Across the dark sea of interstellar space, a star pulses with ancient light. Around it, planets circle in silent, stately procession, their orbits carved by gravity's invisible hand. Yet in the mind's eye, a place where imagination is not bound by the physical strictures of the cosmos, we can envision something stranger still, a civilization so advanced, so hungry for energy, that it dares to encircle its sun with an immense structure, a cosmic shell or swarm, gathering the star's radiance for its own purposes. This is the vision of a Dyson sphere, a concept at once audacious and haunting, stretching the limits of engineering and the boundaries of our cosmological curiosity. Settle now into the gentle thrum of this stellar dance, where science and speculation intertwine. Let us drift closer to this hypothetical marvel, exploring not just its grand silhouette against the stars, but the myriad intricacies that compose its reality, the daunting challenges that must be overcome, the subtle signatures it might leave upon the universe, and the ongoing quest to detect such wonders across the vastness of space. The idea of a Dyson sphere, first crystallized in the writings of the British-American mathematician and physicist Freeman Dyson in 1960, was never meant to conjure the image of a solid, rigid shell, a hollow sphere encasing a sun, as if a cosmic snow globe. Rather, Dyson spoke of a swarm, a loose collection of orbiting satellites or habitats, each sipping the star's light, collectively capturing a significant fraction of its energy output. The underlying logic, though, is breathtaking. The energy needs of an advanced civilization would inevitably outstrip what could be gathered from its planetary surface. If life were to reach out, to transform its environment on a truly astronomical scale, what greater prize than the full power of a star? But to even begin to imagine such an edifice is to confront the staggering scale of the challenge. Consider the Sun, the heart of our solar system, pouring forth nearly 400 yottawatts of energy, an incomprehensible blaze, 1,000,000 times more than all the energy used by human civilization each year. To harness even a fraction of this would require technology and resources orders of magnitude beyond anything we now possess. The raw material alone is daunting. If we wished to build a thin shell at the Earth's orbit, just a few meters thick, we would need more matter than is contained in all the planets of our solar system combined. And yet, the allure of such a project is irresistible, for it represents not just technical prowess, but the very apex of civilization's journey, to become, in the terminology of the Russian astronomer Nikolai Kardashev, a Type II civilization, one that commands the energy of an entire star. Let your thoughts spiral outward, following the orbits of hypothetical solar collectors, each an artificial world unto itself. These might be massive satellites, perhaps kilometers wide, covered in gleaming photovoltaic arrays, sipping starlight and beaming energy to their creators via focused microwaves or lasers. Or they could be more exotic still, swarms of nanobots or dust-like particles, guided by electromagnetic fields, forming a shimmering, shifting veil around the star. The mechanics of such a system are a ballet of orbital dynamics. Each collector must maintain its path, avoiding collisions with its countless brethren, adjusting for the gravitational tugs of planets and the subtle pressure of sunlight itself. And here, within the mathematics of orbital mechanics, we find one of the first great intricacies. A solid sphere, rigid and unmoving, is a fantasy. It would be crushed by the unrelenting pull of gravity, or torn apart by the star's own convective violence. Even a loose shell is fraught with hazard. The orbits of its components must be meticulously tuned. Too close to each other, and mutual gravity could cause collisions or catastrophic clustering. Too spread out, and the structure loses coherence, failing to gather much of the star's radiance. The swarm model, then, is a kind of compromise, a dynamic, living system with countless independent pieces in coordinated motion. Yet even here, challenges abound. How to harvest and store such vast energies without destructive feedback? How to shield delicate machinery from the star's storms of radiation and ejected plasma? How to maintain stability over millennia, as orbits decay, as cosmic dust accumulates, as the star itself evolves and changes? Each question is a branch on a tree of engineering dilemmas, each rooted in the immutable laws of physics and the relentless entropy of the universe. To build a Dyson swarm, a civilization would need not just gargantuan resources, but an exquisite mastery of materials science and autonomous manufacturing. Imagine fleets of mining drones, stripping asteroids and small moons of their metals and ices, processing them in orbit, weaving them into thin, resilient structures. Advanced nanotechnology might be required to assemble complex systems molecule by molecule, creating materials stronger and lighter than anything nature provides. Self-replicating machines, von Neumann probes, might spread throughout the system, multiplying and constructing new habitats and collectors at a geometric pace. And all of this must be orchestrated with precision, for a single miscalculation could send fragments of the swarm careening into one another, triggering a chain reaction of destruction. Yet even as we conjure these wonders, we must remember the relentless constraints of reality. The sun is not a gentle passive orb. Its surface seethes with magnetic storms, belching flares and coronal mass ejections that can engulf planets in waves of charged particles. Any collectors or habitats must be shielded against this fury, or be able to ride out storms without catastrophic failure. The radiation environment so close to a star is harsh, battering electronics and weakening materials over time. Cooling is another subtle but crucial problem. As collectors absorb energy, they themselves become hot, radiating heat away into space. To avoid overheating, they must be designed to dissipate energy with exquisite efficiency, perhaps using vast radiators or sophisticated heat pumps. The economics of such a venture are equally daunting. Even with near-perfect recycling and self-replication, the sheer scale of construction boggles the mind. The time required, even for a civilization vastly more advanced than our own, would be measured in centuries or millennia. The coordination required among billions or trillions of independent units is a problem of staggering complexity, demanding artificial intelligences of unprecedented sophistication. And yet, when one contemplates the possible motivations, the obstacles are put into perspective. Energy is the currency of life and progress. For a civilization seeking to expand, to power vast computing networks, artificial worlds, or ambitious experiments, the lure of a Dyson swarm is irresistible. Perhaps, for a species that has mastered its environment, it is the only logical next step. But let us drift now from the realm of construction to the shadowy domain of detection. For if such megastructures exist, scattered across the galaxy, could we hope to find them? Could we, peering through our telescopes, glimpse the signature of a civilization that has wrapped its sun in artificial garlands? The search for Dyson spheres is, in many ways, a search for anomalies, a hunt for stars that do not behave as they should. A star shrouded in a Dyson swarm would not vanish from view, but it would be profoundly changed. The collectors would intercept much of the visible and ultraviolet light, absorbing it and re-radiating the energy as waste heat, most likely in the form of infrared radiation. Thus, the hallmark of a mature Dyson sphere would be a star that glows dimmer than expected in visible light, but shines with a peculiar excess in the infrared. This, then, is the signature we seek, a star whose spectrum has been distorted. whose light has been transformed by technology on a cosmic scale. Astronomers have scoured the heavens for such objects using data from infrared surveys like those of the IRAS, Infrared Astronomical Satellite, WISE, Wide Field Infrared Survey Explorer, and the Spitzer Space Telescope. The hope is to find something that cannot be easily explained, a star emitting less visible light than its peers, but far more heat, as if swaddled in a cosmic cocoon. Yet the universe, in its vastness, is a place of confounding complexity and deceptive mimicry. Nature provides many ways for a star to shroud itself in dust and darkness. A young star still forming is often wrapped in a thick disk of gas and dust, absorbing starlight and glowing fiercely in the infrared. Older stars, nearing the end of their lives, shed their outer layers, creating expanding shells of dust that likewise alter their spectra. Even clusters of comets or fields of interstellar grains can produce infrared excesses, masquerading as the signature of a Dyson sphere. Discerning artificiality amid this cosmic noise is a profound challenge. Astronomers must sift through catalogues of objects, comparing their spectra, their ages, their locations, and their context, hunting for outliers that defy conventional explanation. The process is painstaking and fraught with uncertainty. A handful of candidates have been proposed: stars with unusual infrared profiles or peculiar dimming events that might hint at orbiting structures. The most famous of these is perhaps KIC 8462852, also known as Tabby's star, whose unpredictable asymmetric dimming patterns sparked wild speculation about alien megastructures. Yet further observation revealed a more mundane explanation: clouds of dust drifting through space, blocking the star's light in irregular patterns. Still, the quest continues, for the signature of a true Dyson swarm might be subtle or well camouflaged. An advanced civilization might deliberately design its collectors to be nearly transparent, avoiding detection. Or it might choose to construct its swarm in orbits far from the star, reducing the temperature of the waste heat and shifting the signature into longer, harder-to-detect wavelengths. The possibilities are as varied as the potential motivations of the builders. There are other, more subtle clues we might hunt for. The presence of vast artificial structures could alter the orbits of planets or produce faint, regular transits as collectors pass in front of the star. Perhaps the very pattern of waste heat, the precise spectrum and distribution, could betray the hand of intelligence if we only knew what to look for. Some have even suggested searching for the byproducts of computation or communication, radio emissions with unnatural regularity, or optical pulses with the hallmarks of deliberate modulation. Yet all these efforts are shaped by the fog of our own ignorance. We do not know what a truly advanced civilization might choose to build, or how it might wish to reveal or conceal itself. Our search is guided by analogies to our own technology, our own needs and desires projected onto the canvas of the cosmos. Step back then and appreciate the delicate, intricate dance between the ambitions of hypothetical builders and the subtle clues they might leave, between the physics of starlight and the ingenuity of those who seek to harness it, between the limitations of our instruments and the boundless possibilities that lie beyond their reach. In this dance, each step is shaped by the interplay of energy and matter, of entropy and order, of the known and the unknown. As we drift further into the night, the image of a Dyson swarm shimmers at the edge of possibility, both a beacon and a challenge. It calls to us not just as a feat of engineering, but as a mystery to be unravelled, a question whispered across the void. Are we alone in our ambitions, or do others elsewhere encircle their suns in webs of light and shadow? The answer, if it exists, is hidden in the delicate patterns of starlight, in the tangled signatures of dust and heat, in the silent music of the spheres. Beyond these intricacies, other questions linger, deeper still and more profound. What would it mean for a civilization and its star to be so entwined? How would life flourish in the shadow of such a creation? What stories would unfold beneath the eternal, artificial dawn? These mysteries beckon us onward, their answers just out of reach as the cosmic dance continues. Among the infinite strands of starlight unfurling across the cosmic sea, human curiosity has always been drawn to the rare and the grand, those improbable dreams that exist just at the edge of possibility. As our knowledge of the universe deepens, so too do our aspirations. The idea of the Dyson sphere, that vast mantle of energy-collecting structures enveloping a star, remains as much a symbol of our yearning to understand as it is a hypothetical feat of engineering. But if such celestial giants do exist out there in the unfathomable dark, how might we, mere denizens of a small blue world, ever hope to find them? The hunt for Dyson spheres is, in truth, a story of ingenuity, patience, and a peculiar kind of seeing, a way to look not for what is present, but for what is absent, obscured or transformed by the shadow of intelligence. The search begins, as so many cosmic quests do, with our telescopes. These are not simply glass lenses peering up from mountaintops, but arrays of instruments that taste the night in every flavor of light. Our eyes, limited to the narrow rainbow of visible colors, are but one set of senses. The universe, however, speaks in ultraviolet, in radio, in X-rays and microwaves, and the subtle warmth of infrared. It is in the infrared, especially, that the first hopes of Dyson sphere hunters are pinned. A Dyson sphere, if it existed, would fundamentally alter the way its star shines. The visible light, that luminous outpouring we associate with the sun, or the myriad points of brilliance scattered through the Milky Way, would be intercepted by the sphere's myriad panels or swarms of satellites. That energy, harvested for unimaginable purposes, would warm the structure itself, heating it as surely as sunlight warms your skin through a window. Yet nothing is ever perfectly efficient. The waste heat, the inevitable byproduct of any real system, would radiate away, not as visible light, but as a slow, steady glow in the infrared. The star would vanish from ordinary view, replaced by a ghostly ember, a beacon visible only to those who know how and where to look. So it is that astronomers, armed with vast sky surveys, comb through fields of data. The search for Dyson spheres is, in large part, a search for the anomalous, those stars that are inexplicably dim in optical wavelengths, but unexpectedly bright in the infrared. The Infrared Astronomical Satellite, IRAS, launched in 1983, was humanity's first attempt to map the sky in the infrared, revealing a hidden universe of dust-enshrouded stars, cool galaxies, and the warm afterglow of cosmic birth. IRAS's data, and that of its successors, the Wide-Field Infrared Survey Explorer, WISE, the Spitzer Space Telescope, and the Herschel Space Observatory, has been sifted for decades, each new instrument peeling away another layer of obscurity. But the hunt is not so simple as matching a checklist. Many natural phenomena can mimic the signs of a Dyson sphere. Stars wrapped in thick cocoons of dust, their visible light absorbed and re-emitted as heat, are common in the tumultuous nurseries where new suns are born, or in the dying throes of old giants. Entire galaxies, shrouded in interstellar debris, can glow in the infrared with a fervor that rivals the predictions for artificial megastructures. To distinguish the hand of intelligence from the chaos of nature, astronomers must become detectives, sifting through the clues with care. A promising candidate for a Dyson sphere, a star that is unusually dim in visible light, yet bright in the mid-infrared, must first be ruled out as a more prosaic object. Astronomers cross-reference catalogues looking for signs of youth, of stellar death, of the presence of dust or gas that might explain the anomaly. Spectroscopy, the art of splitting light into its constituent wavelengths, becomes a powerful tool, A natural dust cloud will reveal itself through specific absorption lines, the fingerprints of molecules and atoms, while an artificial structure might present a smooth, featureless spectrum, like the uniform glow of a blackbody radiator heated to the precise temperature that would make it an efficient energy collector. In this way, each candidate is weighed, measured, and often discarded, the promise of discovery tempered by the rigors of skepticism. Yet the search is not limited to single stars. Some visionaries have suggested that entire galaxies could, in theory, contain advanced civilizations who have constructed Dyson spheres around millions of suns. Such a galaxy, stripped of its visible brilliance and glowing instead with a deep red warmth, would stand out as an oddity in surveys of extragalactic light. Researchers have combed through catalogues of galaxies, looking for those whose spectral signatures deviate sharply from the norm, whose energy output is skewed toward the infrared. So far, nature has proven more inventive than artifice. Starburst galaxies, active galactic nuclei, and other cosmic forges can produce similar effects. Still, the search continues, each new dataset a fresh field for the hopeful. Beyond the passive act of observation, there are other, more subtle methods. Some researchers have proposed searching not for the direct effects of a Dyson sphere, but for the secondary consequences, a traffic jam of comets disrupted from their usual orbits, or the gravitational tug of missing mass where a star's light has vanished, but its presence is still felt. Others suggest monitoring the flicker and dimming of stars with exquisite precision, looking for the telltale signature of megastructures in motion, their components passing between us and the star in a slow, deliberate dance. The Kepler Space Telescope, designed to hunt for exoplanets by watching for tiny dips in starlight, has provided a dataset of unprecedented depth. Among its millions of observations, a handful of stars have shown strange, irregular dimming, most famously the enigmatic KIC 8462852, or Tabby's star, whose unpredictable flickers sparked a flurry of speculation. While natural explanations remain more likely, clouds of dust, swarms of comets, the event itself is a reminder of how little we truly know, and how easily our imagination is kindled by the unknown. With each new generation of instruments, our search grows more sophisticated. The James Webb Space Telescope, with its enormous segmented mirror and keen sensitivity to the mid-infrared, promises to reveal details that were once lost in the noise. Its gaze can pierce the veils of dust, unravel the tangled spectra of distant sources, and perhaps, just perhaps, catch a glimpse of something truly anomalous. Ground-based observatories, equipped with adaptive optics and vast digital cameras, scan the sky with relentless precision. The Vera C. Rubin Observatory, soon to commence its legacy survey of space and time, will map the heavens in motion, capturing the subtle changes in brightness across billions of stars and galaxies. The data flood is immense, but so too are our tools for understanding. Machine learning algorithms, trained to recognize patterns invisible to the human eye, sift through the torrents of information, flagging the rare and the peculiar for closer inspection. Yet the quest for Dyson spheres is not merely a technological challenge, it is a philosophical one. The very act of searching requires that we imagine not just what is, but what could be, the shape of alien ambition, the limits of engineering, the signature of intelligence far removed from our own. We must ask ourselves, what would a civilization capable of such feats choose to do? Would they hide their works, cloaked in stealth and subtlety, or would the laws of thermodynamics betray them, their waste heat radiating into the universe like a silent confession? Might there be other forms of energy collection, other architectures we have not yet conceived, lurking beyond the reach of our current imagination? As our methods grow more refined, so too do our expectations. The early vision of a Dyson sphere as a single, solid shell has given way to more plausible scenarios. swarms of collectors, clouds of satellites, each harvesting a fraction of their star's light. The signatures we seek may be fainter, more complex, scattered across wavelengths and time. A swarm might not block out all visible light, but merely dim it or modulate it in patterns that hint at artificiality. The waste heat might be spread across a range of temperatures, the spectrum smeared and blended with the background. The challenge, then, is to tease out these threads from the tapestry of the cosmos, to recognize the handiwork of intelligence in the midst of nature's riot of forms. The story of the hunt is also a story of patience. The universe is vast, its timescales immense. The signals we seek may be rare, their sources scattered across millions of light-years. It is possible, likely even, that many Dyson spheres, if they exist, are simply beyond our current reach, their faint warmth lost in the cosmic noise. Yet each new survey, each new instrument, brings us closer, expanding the sphere of our awareness, sharpening our tools for discernment. There is a quiet poetry in this search, a sense of communion with minds unseen. To look for Dyson spheres is to acknowledge the possibility of other stories unfolding in the dark, other dreams made manifest in the language of physics and engineering. It is to imagine that somewhere someone has solved the riddles we still ponder, has built on a scale that dwarfs our own, and has left a trace for us to find, if only we look carefully enough. And so the search continues, relentless and patient, a symphony of observation and analysis. Each candidate is weighed, each anomaly dissected, each theory refined in the crucible of data. The sky is mapped and remapped, the spectra catalogued and compared, the algorithms tuned and retrained. In the process, we learn not just about the possibility of Dyson spheres, but about the universe itself, its dust and gas, its stellar births and deaths, its galaxies in collision and collapse. Every false positive, every natural mimic is a lesson in the complexity of the cosmos, a reminder that nature's creativity rivals our own. Yet always in the background the question persists, what would it mean to find such a thing? What would it feel like to detect, amid the cacophony of stars, the unmistakable signature of a celestial giant, an artifact of intelligence vast and ancient, quietly harvesting the energy of a sun? Would we recognize it when we saw it, or would it slip past us, unnoticed amid the noise? Would the discovery change us, alter our sense of place, or merely confirm what we have long suspected, that the universe is stranger, richer, and more full of story than we can yet imagine? The hunt for Dyson spheres is in the end a dance between knowledge and wonder, skepticism and hope. It is a testament to our capacity for curiosity, for patience, for the willingness to search the night for signs of something greater. Our tools grow sharper, our surveys deeper, our models more refined. Yet the sky remains vast, its secrets well kept. Even now, as data flows from distant telescopes and algorithms past the heavens, new questions arise. Could there be other signatures, subtler still, that we have not yet learned to seek? Might there be technologies so advanced that they leave no trace at all, or ones that manifest in ways entirely alien to our expectations? The search, it seems, is never quite finished, each answer breeding a new generation of mysteries. And so, with our gaze fixed on the night and our instruments tuned to the faintest whispers of heat, we press on, drawn by the promise of discovery, the hope of contact, and the simple, enduring joy of the hunt. The universe awaits, vast and enigmatic, its giants hidden or revealed by the play of light and shadow. And we, ever curious, continue our quiet vigil beneath the stars, listening for a signal, watching for a sign, ready for whatever may come next. Let your mind drift, as though you are floating in the gentle darkness between stars, weightless and unbound. Above, below, in every direction, the cosmos stretches out, an ocean of light and shadow, mystery and memory. Here, far from the urgency of daily life, we find ourselves on the threshold of the profound, pondering the discoveries that have forever altered our sense of belonging. Imagine, if you will, the epical moment when humanity, after centuries of searching, at last glimpsed the unmistakable sign of a Dyson sphere, a structure built to encompass a star, drawing forth its energy to power the works of minds unimaginably advanced. In that instant, the universe grew both smaller and infinitely wider. Pause for a moment and sense the tremor such a discovery would send through the collective consciousness of Earth. Science fiction had long flirted with the idea, civilizations so old and wise that they could bend the architecture of their solar systems to their will, capturing the energy of suns, building worlds from the dust of comets, weaving habitats like necklaces of light around their parent stars. When our telescopes, peering into the depths of the Milky Way, finally caught the signature, a star's output, dimming and flickering in a way that nature alone could not explain, the news circled the globe with the hush of awe and the electric thrill of revelation. What does such a discovery mean for us, the inhabitants of a small blue planet? It is one thing to gaze up at the night sky and wonder if we are alone, and quite another to encounter evidence so vast and intentional that it reshapes the very question. The Dyson sphere, by its nature, is not merely a structure. It is a declaration of existence, of persistence, of intelligence, reaching beyond the cradle of its world. It is a cosmic artifact, not left behind by accident, like a drifting probe or a whisper of radio static, but a monument to purpose and the will to endure. Let us breathe in the gravity of this realization. For centuries, philosophers and poets have debated the nature of our place in the universe. Are we a happy accident, a fleeting spark in the dark, or the first note in a symphony yet to begin? The detection of a Dyson sphere does not answer these questions, but it changes the tone of the asking. Now we know that life has found a way not only to survive, but to thrive, to shape its environment on a scale once reserved for gods and myths. Consider the shift in our self-regard. Before this moment, our greatest achievements, landing on the moon, sending probes to the outer planets, building the International Space Station, felt monumental, yet modest against the background of eternity. Now, with evidence of star-encompassing engineering, our triumphs seem both smaller and more precious. We stand at the beginning of a long path, a journey that others have walked before us. In this knowledge, there is both humility and hope. Imagine the philosophers gathering in quiet rooms, the scientists debating through the night, the artists painting visions of what might lie within those shrouded spheres. Some would feel diminished, their sense of uniqueness challenged. Are we just one of countless civilizations, each blazing briefly and then fading? Yet others would feel a rush of kinship, a sense that intelligence is not a lonely accident, but a thread woven through the cosmic tapestry. If others have built Dyson spheres, then perhaps the universe is not indifferent, but fecund, fertile ground for mind and meaning to arise. The religious and spiritual implications ripple outward as well. For those whose faith is grounded in the singularity of humanity, the presence of the Dyson sphere is a test, a call to reconsider what it means to be chosen or cherished. For others, it is a confirmation. The universe is grand enough for many children, each on their own journey toward the divine or the transcendent. The discovery does not erase our stories, but invites us to see them in a wider context. Yet beneath the tumult of ideas, a quieter, more personal question emerges. What does it feel like, deep in the marrow, to know we are not alone? Is it comfort or terror? For some, the idea of neighbors among the stars is a balm, an assurance that the universe is not silent. For others, it is unsettling, a reminder of our smallness and vulnerability. But perhaps the truth is more intricate, a weaving together of awe and humility, curiosity and caution. Let us return to the night sky, now forever changed. Each point of light is no longer merely a sun, but a potential cradle of life, a possible home for minds and dreams. The discovery of the Dyson sphere does not tell us who built it or what became of them. Their signals may be silent, their stories lost to dust and time. Yet their work endures, a testament to the urge to endure, to reach beyond the limits of biology and geology, to become part of the dance of matter and energy that shapes galaxies. Here in the quiet hours it is natural to wonder, what would it mean for us to follow in those footsteps? The Dyson sphere is not only a signpost but a challenge. Are we capable of such ambition, or are we doomed to remain within the bounds of our own world, limited by fear or division? The dream of harnessing a star's energy, of building habitats that circle the sun like beads on a string, is both a technical and a moral question. Can we grow wise enough to wield such power without destroying ourselves? Can we learn to see ourselves as stewards, not only of Earth, but of the wider cosmos? The philosophers of old spoke of the great chain of being, a hierarchy from minerals to plants, to animals, to humankind, and finally to the divine. The Dyson sphere invites us to imagine a new chain, not of superiority, but of possibility. At one end, the humble molecule drifting in the cold depths of space. At the other, the works of intelligence, cities on moons, gardens orbiting distant suns, the light of consciousness flickering through the void. We are part of this chain, both builders and inheritors, shaped by forces we barely comprehend, and yet driven to reach for what lies beyond. There is a paradox at play. The more we learn of the universe, the more intricate and interconnected it becomes. The cosmic web binds galaxies together, gravity loops the orbits of planets and moons in ceaseless motion, and now the presence of the Dyson sphere hints at a different kind of connection, a kinship of purpose across unimaginable distances and epochs. Are we, perhaps, participants in a dance that began long before we were born, a choreography of curiosity and courage that will persist long after we are gone? Think of the silence that falls after the initial discovery, the way the world holds its breath. In that hush, new questions unfurl. What stories linger inside those artificial shells? What hopes and fears? What triumphs and failures? The Dyson sphere is a mirror as much as a mystery. In its presence, we see not only the achievements of another civilization, but the outline of our own potential. We are reminded that the universe is not a fixed stage, but a living, changing theatre. The actors may come and go, but the play endures, ever richer for each voice that joins the chorus. Perhaps, as the centuries pass, humanity will reach out in response, not with weapons or conquest, but with curiosity and care. The Dyson sphere becomes an invitation, a summons to grow, to learn, to imagine ourselves as part of a larger story. We will send our probes and our questions, our mathematics and our music, hoping that somewhere there is a listener, a kindred mind, tracing the same spiral of wonder. In the meantime, life on Earth continues much as before. The tides rise and fall, children laugh in sunlit parks, the seasons turn. Yet beneath the surface, a subtle change is taking root. Our sense of isolation is softened. The knowledge that we share the universe with others, even if distant and unknowable, adds a new layer to the meaning of existence. It becomes harder to believe that our quarrels and divisions are the sum of what matters. The stars are not only destinations, but reminders of what we might become. Science, too, is transformed. The search for knowledge is no longer just a quest for survival or comfort, but a way of joining the ongoing conversation of the cosmos. Each experiment, each observation, each equation scribbled on a chalkboard is a step toward understanding not only the universe outside, but the universe within, the patterns of thought and feeling that drive us to ask, to seek, to dream. The arts, always porous to the winds of change, blossom in the wake of discovery. Poets write of suns wrapped in veils, of minds that dream in centuries, of the music of photons echoing through engineered halls. Painters and composers, sculptors and storytellers find in the Dyson sphere a symbol of both aspiration and enigma, a reminder that the greatest works may outlast their creators, and that meaning is woven not only from answers but from questions. And so, in quiet moments, we gaze up at the night sky with new eyes. The constellations shift and shimmer, familiar yet altered. Each point of light is not merely a marker of distance, but a promise, a sign that the universe is capable of more than emptiness, that even in the vastness, life finds a way to endure, to create, to leave its mark. The Dyson sphere is both a beacon and a mystery, a challenge and a comfort. It does not diminish us to know that others have climbed higher. Rather, it invites us to imagine what heights we, too, might reach. Amid all this, the question of meaning lingers. What is the purpose of such vast constructions? Is it merely survival, the endless hunger for energy and safety? Or is there something more, a striving for beauty, for connection, for transcendence? The Dyson sphere, silent and inscrutable, does not answer. It is an artifact of intention, a sign that matter can be bent to the will of mind, but it does not reveal the dreams that shaped it. Perhaps that is as it should be, for in the silence between stars, in the spaces between what we know and what we yearn to discover, we find our own answers. The journey does not end with the detection of the Dyson sphere. Instead, it opens a new chapter, a call to deepen our science, to refine our philosophy, to widen the circle of empathy and imagination. And so, as sleep gathers at the edges of your mind, let your thoughts drift outward, carried on the current of cosmic curiosity. The stars remain, ancient and patient, their light a bridge across time and space. Somewhere, perhaps, other minds are watching, wondering, weaving their own stories into the fabric of the universe. In this great dance, we are both audience and participant, learning to move in harmony with the music of the spheres, ever reaching for the next note, the next step, the next bright possibility that waits beyond the edge of night. As our journey through the shimmering possibilities of Dyson spheres drifts to a close, we float gently like a comet tail fading into the hush of space, pondering the quiet mysteries of distant civilizations. May this calm voyage inspire your dreams to wander among the stars, and when you're ready, return with us for more gentle tales from the vast cosmic night.